Bismillah ar-Rahman ar-Rahim. Today, inshallah, we are going to continue the discussion regarding network access layer. And as we know, the network access layer is composed of the physical layer and the data link layer. So we covered the physical layer, we covered the basic functionality of the physical layer, including the responsibility to connect physical devices with the medium. And also encoding, we talked about encoding schemes and we talked about signaling schemes. We also talked about the different types of media and the properties of each of these types of media. Today, inshallah, we are going to go one level up to talk about data link layer. As we all know, the data link layer is the second layer in the layered stack above the physical layer and the below the network layer. Okay, data link layer, like any other layer, it performs encapsulation and decapsulation, and it's responsible for two basic or two fundamental functionalities, which are in fact divided into two sublayers. So data link layer is a distinct layer, and it's the only layer in the layered stack that is divided into two sublayers. Okay, so first the question is, what are these two sublayers and why are they separated? Why are they separate sublayers? نواف تفضل. Okay. Okay, so why are they separate, يا نواف? Okay. اوكي طيب ماشي. طيب يبقى ده كلام مظبوط. So first of all, these two sublayers are separated because the logical link control is medium independent, which means that it's totally agnostic to whatever physical medium you are using. Whether you are using fiber optics, wireless, copper, coaxial, anything, the logical link control does not care about that. It's totally agnostic to whatever physical medium you're using. Whereas the medium access control, from the name medium access control, it controls the access to the medium, right? So this is heavily dependent on the type of medium we're talking about. So to organize the access to the medium in the case of wireless is different from the case of copper, is different from the case of fiber optics, and so on. Because the physical properties of the medium dictates certain way to organize this access to the medium, and we'll talk about all the details related to this. Another reason why these two sublayers are in fact separated is because of the fact that the physical layer and the MAC sublayer are both implemented in hardware. Okay, because as we can imagine, both are heavily medium dependent. The physical layer is of course medium dependent, and the MAC sublayer is also medium dependent, heavily medium dependent. And that's why both of them, the physical layer and the MAC sublayer, are implemented in hardware. Whereas starting from the logical link control all the way up, all these other layers, or including the logical link control sublayer, are implemented in software. Also, the protocols in the network layer are implemented in software. So they run as actually processes. So you have process 1, process 2, process 3, and so on. So these processes, they run as software processes, and they deal with the protocol data unit in that sublayer, as we will talk in a minute. Okay, كده? So the two reasons why we separated these sublayers is because of the fact that logical link control is medium independent and is done in software, whereas the Mac sublayer is done using hardware and it's medium dependent. Okay. Type. Logical link control is responsible for accepting the protocol from the network layer, and it does a very important functionality, which is error checking. Okay. So error checking is done by the logical link control. And by error checking here, we mean that we have to take the protocol data unit in the data link layer, which, as we have discussed before, it's composed of header and trailer. And we'll talk about why we need header and trailer in the data link layer. That's also another distinction for data link layer. And we have the data in the middle. Okay, so error checking is actually part of the trailer here, and we will talk about the frame structure in a minute. Okay, so this is for this field is used to check whether there is any kind of error in the data or not. Okay, so the error in the data is caused by what? What would cause the error in the data? Any guess? The error in the data is caused by what? Is possibly caused by what? No guess? انتوا معايا يا شباب متابعيني ولا؟ Okay. Okay. So when you send the data from the source to the destination, okay, the data at the end of the day is transferred as a digital signal, right? This digital signal has, as we said, some environmental characteristics that affects the signal inside this physical medium. And the result of this could be the fact that we add some noise, so the data gets corrupted, which means that some of the zeros and ones in the data, they get switched. The zero becomes one or one becomes zero. In which case, this error checking will say, oh, okay, so there seems to be some change in the data, so I will not accept this data at all. So that's the functionality of the logical link control. So regardless of whatever type of medium, the logical link control performs the error checking in the exact same way. There's no difference whether it's fiber optic or anything. Okay, so the Mac layer, it actually controls access to medium. Okay, and the best way to understand this, and we will explain this in a lot more details later, inshallah, in the next chapter. The best way to understand the Mac layer is to imagine that we have like a shared medium and we have multiple users here, and these users, they are trying to share that medium. So as we said before, so someone has to organize the access to the medium to facilitate a specific node to access that shared medium at any point of time. So in other words, let's assume that we are in a meeting, like in a meeting كده peer to peer, and we are discussing a certain issue. So in that case, we have to organize that meeting that one of us will have access to the floor at any point of time. So whether we have a moderator to this meeting to organize this access, or whether we take turns or something like that, but we have to arrange the access to the medium. So similarly, this is the functionality of the Mac sublayer. Okay, كده? طيب, so the Mac sublayer, for that, using a specific type of addressing, which is the physical addressing. So logical link control uses the error checking field, and the MAC layer uses the addressing, which is actually one field here in the header. So that's the addressing, as we will see in a minute. ماشي كده؟ So this addressing اللي هو ايه بقى physical address, which is the name of the person. As we said before, the physical address is a permanent name for that device, whether it's an end device or a network device, and it stays with that device permanently. Okay, it's like the name of the person, and it's not the logical address, which is used as part of the network layer, which is used for indicating where that person is, the location of that person. Okay. So that's the main functionality of the logical link control and the MAC sublayer. Okay. طيب. Another question, which is the fact that in the header. In the header, we have or we can talk about this as part of the activity next, inshallah, مش مشكلة. So remember that the logical link control is done in software, and all the protocols in these software layers, they run as processes. Okay, that's very important. So the first activity here, if we need to go back here, remember we said that protocols run as software processes in the upper layer. Okay, so in the logical link control, I have to send the data structure in this logical link control into one of these processes. Okay, because in the network layer there are multiple processes. One process represents IPv4. One process represents IPv6. One process represents ICMP, and so on. So we have many protocols like this, right? So the logical link control has to send the data structure, which is in our case the packet, to one of these processes. Okay, so how do we do this? Through the talks about the generic frame structure. The word generic here is very important. Okay, the word generic means that this is the abstract definition of the data link layer protocol data unit. So this is the protocol data unit in the data link layer, and this is abstract, which means that it's part of the, remember we talked about the ISO OSI reference model, which defines an abstract specification for a specific layer without matching or without aligning this to a specific standard. So this is the generic definition or structure of the data link layer protocol data unit with no perception about what standards we're talking about. Okay, so this frame structure does not assume certain standards, whether it's Ethernet or anything. Okay, so that's very important. Okay, so the activity here talks about how to match these boxes in these locations. Okay, but more importantly, we need to discuss why do we need certain fields in these locations. Okay, what is the functionality of each field. Okay, so we need to talk about these details. So we don't want to just match blindly and that's it. So some people, they complain about having to memorize everything. By discussing these things, we help you to understand why these fields exist in that location and why they are used for, so that we simplify the fact that we can remember the structure of this data link layer protocol data unit. So I'll give you 1 minute to to match these boxes in the proper location, and more importantly, think about the functionality of each field and why do we need that field in that particular location. Okay, anyone finished? Okay. So first we'll talk about the frame structure collectively. So we discuss it collectively. So the first part here, we start from here and then we go all the way down. So the first one here is the header. Okay, and then in the middle here we have the packet. By packet here we mean the protocol data unit in the network layer. Okay, which for us as a data link layer is just data. And then the trailer. Okay, then we want to now give more details about the header and the trailer. In the middle, we know that we have the data. Okay, so here we have the data, but what about the on the left hand side? So the first field is from the left. Anyone can frame start. تمام، يبقى أول حاجة frame start. Okay, and then addressing. تمام, and then type. صح, and then control. تمام. At the trailer side, we have the error checking or error detection, and then the frame stop. Okay. طيب. So first of all, we need to understand about so many things. Why in the data link layer we have both header and trailer? Why do we have to have frame start, okay, and frame stop? Why do we need to have frame start and frame stop? Whereas, by the way, these two fields, they do not exist in any other layer. Neither in the physical layer, nor in the network layer, nor in the transport layer, no other place other than the data link layer. So why specifically in the data link layer we have to have frame start and frame stop? Huh? Anyone knows the answer? Why do we need to have frame start and frame stop in the data link layer and not in any other layer? عبد الرحمن تيسير اتفضل. ايوه ايوه why in the data link layer or in the max sub layer but it does not exist in any other layer? It doesn't exist in any other layer. It does not exist in any other layer. So why specifically in the data link layer? Okay, so what happens is, remember, the data link layer, okay, is the first, or the max sub layer, yani, is the first sub layer above the physical layer. So in the physical layer, what we have in the physical layer here, what we have is zeros and ones. Okay, so it's no specific structure. We don't have any specific structure. Okay, just bits, and in fact we might have certain gaps, silent, nothing. Okay, and then we have some bits. Okay, so when we have a stream of bits like this, okay, in the data link layer we cannot process these bits unless we have to form a data structure out of these bits. Okay, so the data link layer is the first layer that converts the serialized bits or the stream of bits into a structure. Okay, So in the data link layer, we have header, and we have data, and we have trailer. Okay, so we have to convert the bits into a structure. Maybe. So what happens, the way we do it is just to allocate a certain bit pattern, which is like 0 and then 1, 1, 1, 1, 1, 0, something like that, to indicate that this is the start of a new frame. Okay, so that's what we refer to as frame start. That has to happen in the data link layer because data link layer is done in hardware, and it has to convert the bits from the physical layer into a specific structure that separates the header from the data from the trailer. Okay, so we have to have a certain bit pattern inside these bits that tells me that this is the beginning of a new frame. Once we have this, in the logical link control, it's done in software, right? So we form a data structure. Remember the structure in C or a class? So we form a structure that has a header. This is one parameter, the data, and the trailer. And the data is just a pointer that we can later on pass to the upper layer, and from then on we can deal with a specific structure, with a specific data structure. However, the data link layer is the first layer that has to convert unstructured bits into a well-structured format. واضحة دي يا جماعة؟ So that's why we need to have the frame start and the frame stop. طيب. Then again we have the addressing field. So why do we have the addressing as the very first field after the frame start? Why in the beginning of the frame? And in fact, the addressing in the data link layer, you will notice something. I'm not sure if some of you will notice this, but you will notice something, that the address in the data link layer starts first with the destination address and then the source address. But all the other layers, network layer and so on, they actually start with the source address and then destination address. So why in the data link layer we have the addressing at the very, very beginning, and in fact we have the destination address as the first field in that frame structure? محمد عبد الله، اتفضل. اتفضل. The frame data is here. Okay. طيب. You did not talk about the addressing. Why the addressing is in the beginning of the frame? أيوة. They do not need to read the frame data. يعني انت عايز تقول ان هم all they need to read اللي هو الادرس بس. Like ايه بقى زي ما انت قلت؟ switches. يعني switches, they what they do is that they don't need to read anything from the data link layer frame except the destination MAC address or the destination physical address. That's the only thing they need to read. And then they perform their functionality. As we all again mentioned before, that the data link layer is done, or the MAC layer is done in hardware. So the way we perform any functionality with the hardware is that we have hardware circuits that read in sequence. So at the beginning, the hardware reads the frame start, so it knows that this is the beginning of a new frame. And then what it needs to do is, like switches, for example, they need to read the destination address, and then they don't need to read anything else. They just pass the frame based on the destination address, as we will see in later chapters. So that's correct, Muhammad. So that's why we need the addressing as in the beginning of the frame, so that we speed up the processing in hardware. We just read the destination address, and then we send the frame over. Type. What is the type? What is the type, and why do we need that type? Anyone can explain the functionality of this type field and what it's used for? ثانية واحدة، I did not give you the permission. مين اللي بيتكلم؟ and I did not give anyone permission. It's okay. طيب نواف اتفضل. Okay. IPv4. تمام. So why do I need to have this protocol in the data link layer is to refer to the protocol in the upper layer. تمام يا نواف. So to understand بقى يعني why do we need to do this field? So that type field is the one that tells us that this frame has to be processed by IPv4 protocol and not IPv6 and not ICMP and so on. ماشي كده؟ طيب. The control field is used for two things: reliable communication and flow control. And we will talk about these functionalities in details later on. But remember, again, the ISO reference model defines the fact in abstract way طبعا that this control field needs to be used for reliable communication and flow control, but it does not say any other details. It does not mention any details. So it's up to the standards to take this and define in more details what the control field or how the control field can be used for reliable communication and flow control. ماشي? And then the data, and then the error checking. The error checking, as we said, or the error detection, as we said, is used to detect any possible errors in the data part. If there is any possible error in the data part, which might be caused by environmental phenomena, in that case, we do not send that frame any further, okay? Because there is no point of sending a frame that has any error. Okay, look, like for example, a switch might detect that the frame has certain errors, in which case the switch will not send it further to any other device. Any end device might check that the frame has any error. So in that case, the data link layer will reject that frame, will destroy it, and will not send it up to the network layer. Because again, there's no point of sending any data in the upper layers or in the next device, okay, while the data has an error. So in that case, I will waste the time of other devices for no reason, okay, because the data has certain errors. So that's why this error detection is again, the ISO reference model does not define the details how the error detection can be done, because again, that's a process that's it has certain details, and it can be done in different ways. So the ISO reference model does not define these details as part of the abstract definition. ماشي كده؟ طيب, the frame stop is like frame start is used to indicate that this is the end of the frame. As we will see later, that this frame stop is in fact optional. And some standards, they ignore it. They don't actually use frame stop. And we'll talk about why. But again, the ISO reference model tries to be abstract. It's not related to a particular standard, and it's not related to any specific physical medium, but they define the generic definition of the frame structure. Okay, so now we have an idea about the functionality of each frame and why this frame exists in that location. طيب. So this exercise in that case is very straightforward. I will not give you any time to actually go through it because it's very simple. So the first one here talks about the fact that this field contains. Here we're talking about the generic frame structure fields. Okay. So from here, this contains the IP header, transport layer, PDU, and data. So this is which field is this? Anyone can answer that. Yeah, this is actually the data, because as we said before, the frame structure here contains the header and the trailer, and in the middle here there is data. But in fact, this data is this is the packet in the network layer, which in fact contains the network header and the transport header and the actual application data. Okay, as we said, in each layer we have header and data. The data is a generic term. Okay, the data here is a generic term. If you go to the upper layer, this data field has to be divided into header and data. Okay, and then you go up, the data part will be divided into header and data, and this is the process of decapsulation. ماشي طيب. It identifies layer 3 protocol used by the logical link control. This is the type field. ماشي طيب. Marks the end of the frame. This is a frame stop indicator. ماشي. Identifies source and destination host. This is a addressing. And then specifies special flow control services. This is the control field. As we said, control is used for reliable communication and flow control. Type. So that's the generic frame structure, which is defined as part of the ISO reference model. In the next chapter, we will talk about the Ethernet frame structure, in which case you will find some differences between the abstract definition and the Ethernet frame structure. You will find a lot of differences between the two, because in the Ethernet, now we're talking about the protocol model, which maps to a particular standard, and in that case, we will talk about more details related to the frame structure. Here, we need to talk about the standards and what organization developed that standard. So these are the network access standards. These are some of the standards in the network access layer, which is again composed of the physical layer and the data link layer, both. Okay, so we need to know which organization developed these standards without actually having to go through the details of each of these standards, but we will give some hints. We will give some hints on these protocols as we go through this activity. So I'll give you 1 or 2 minutes to guess, and then we can talk about it. Just to be clear here, you need to know these standards and which organization developed it, and we'll give you some hints on how to know which organization actually developed these standards. As someone was saying on the chat, that anything that starts with 802 is in fact developed by IEEE. So you have here IEEE, which is the organization that's responsible for developing the standards for network access, particularly for local area networks. Okay, remember here that, as we said before, the logical link control, okay, is medium independent. Okay, and then the MAC layer and the physical layer, they are both medium dependent, right? And they are done in hardware. So that's why actually IEEE develops the standards for the network access layer, physical will data link layer, both, okay? And the standards, if you take a look at the standards, you will see that the logical link control, you have only one possible standard, which is we call it 802.2. Okay, 802.2 is the standard for logical link control, and this is agnostic to all types of medium. However, the MAC sublayer and the physical layer, you have multiple standards. You have 802.3, which is the one that we will study in the next chapter, and this is for Ethernet. Okay, you have 802.4, which is here, which is talking bus. Talking bus talks about some standards for a specific type of network topology, which is a chain topology. We'll talk about this also in the next chapter, but it's enough to know that this is actually not used anymore. It's obsolete. Nobody uses the the token bus standards anymore. It has been deprecated and obsolete from the networks nowadays. Okay. So you have also the 802.11, which is the standards for Wi-Fi, the network access standards for Wi-Fi. And you have also 802.15 for wireless personal area network. You have 802.16, and you have many other. So each of these, they target a specific type of physical medium. Okay, whether it's wireless or copper or fiber and so on, fiber optics and so on. ماشي كده؟ So all these 802, they are developed using IEEE. So anything 802, it's IEEE. ماشي? So that's easy. Anything that has G, okay, or Q is in fact ITUT. So اللي هي International Telecommunication Union. ITUT. So ITU telecommunication. And this also is ITU telecommunication. ماشي كده؟ ITU is responsible for standardizing only the physical layer, which is hardware طبعا, only the physical layer for certain types of physical medium. Like ADSL, we talked about digital subscriber line, which is used for internet access. ماشي? So only the physical layer part. This is for MPLS. You don't have to know much about MPLS. And ISDN is for teleconferencing. Again, you don't have to know the details about all these physical layer standards. ماشي؟ طيب ANSI organization, they are responsible for standardizing the connectors for the cables, for the physical cables, the connectors. So when you have X, and remember we talked about BNC for coaxial connectors. So these connectors are used to connect cables with devices. This is not a specific protocol. These are the standards for the wires, the physical cables themselves. Like for example, RG45. You will see this in the lab. The plastic connector that's used to connect the copper cable, whether it's UTP or STP, to other physical devices. Okay, this X3T9 is for fiber optics. These are the connectors for fiber optics, and we talked about BNC for the connectors for coaxial cables and so on. So ANSI is the organization that's responsible for standardizing these connectors. ماشي كده؟ And of course, the remaining one is ISO, which is responsible for now standardizing بقى the network access layer, but for WANs, not for LANs, for wide area networks, point to point, particularly for point to point links like HDLC. And as you can see here, they call the standards with abbreviation, not بقى 802 مثلا او not G dot something, but they call the standards with the abbreviation. So this is high level data link control. Okay, so this is the WAN standards that is designed by the ISO organization. Any questions about these network access standards? Okay.